Okay, I'm going to talk to you today about a couple of things that we ran into in the end of our collision lab. These were places where we're going to discuss the predictions that were tested in the experiment. And I'm going to do things a little backwards. I'm going to say, oh, look, let's see what kind of experimental results we got, and then give the predictions. So the first experimental result is after these collisions occurred, I wound up with projectiles that wound up falling along circles. And I'm in the center mass frame, so center mass is right in the center of that circle. And I noticed that if I had a trajectory here that plopped that particle down there, which is a measure of the velocity, that's why we use that method that you involve these things taking off, and if they have lots of horizontal velocity, they go further and they wind up in a further place, and so that's our position relative to the position of the center mass is going to give us the velocity. Those guys would come out like that for the projectiles, and another circle describes where, for various kinds of collisions, you would get the targets landing, okay? They were back to back, so the targets would come out in the center mass frame with a position which hence means proportional to their velocity, that would be back to back with the corresponding velocity for the projectile. All right, why is that happening? And why, so let's just say they wound up, no matter which direction they took off in, they always wound up in these circles. So somehow there's, we're going to explain that next, why they were circles, but let's get the connection between the magnitude or speeds of these velocities and the masses. That's what we're going to do, because we're check that prediction. So let's see where that prediction is coming from. Well, I claim that it's coming from linear momentum conservation. Why is that? In the center mass frame, what is the total momentum of this thing? Well, first I start off with the mass of the target times its velocity after the collision, mt times vt, and the rest of the momentum is coming from what the projectile is doing. It's an mp times vp over there. And that's adding up to a big zero. That's the center mass momentum. The center mass isn't going anywhere, it's just sitting there in the middle. And so therefore I can say that this system has total momentum zero. But that gives me a very nice relationship right away between those two velocities after the collisions. It says that mt vt equals minus mp vp. And I can write that out if I want in terms of the speeds. So that's mt vt is equal to mp vp, all right? And therefore, I get a ratio between those velocities of vt to vp that's given by mp over mt. And remembering that these are proportional to the radii, that's the relationship or prediction for the positions of the relative radii of those two circles. Okay, but now the second question is, why should they be circles? And the reason for that turns out to be because these are elastic collision, and we always know energy is conserved. Well, whatever kind of collisions where energy will be conserved, but we know all the energy is just going to be in kinetic energy of the particles. So after the collision happens, let me write down what the kinetic energy of the system is. It's 1/2 mt squared, mt times vt squared plus 1/2 the kinetic energy of this flying away projectile. And that's some constant. That was all the kinetic energy you put in the first place. Now, all I have to show is that no matter what direction they go off in, the speed, the magnitude of those velocity is always the same. Always the same for all the projectiles, always the same for all the targets when they get collided. Okay, so let me argue for the targets having always the same velocity, speed. Okay, I can do that by just taking this relationship up here and saying, well, that means I can write down that Vp here is equal to mt over mp times vt. All right, now I'll put that in over here and see where that gets me. So I have 1/2 mt vt squared plus 1/2 mp mt over mp quantity squared times vt squared is a constant, okay? So what have I done? I've written down two terms that both have vt squared, bunches of masses and stuff, and then said that both of these things added together always gives me the constant, the original kinetic energy. That's a long-winded way of saying that something that just involves masses times vt squared is a constant, all right? So I can just write that down and say vt squared is a constant. But now I'm done, because saying that vt is the same no matter what direction you take off in is to say that these things are winding up on circles. And you could have given the same argument substituting for BP, for vt, to show that vp is speed is always the same. So that's why we know that there's always going to be circles.